Hey guys, so for your first flipping video, you need to make sure that you're taking really good notes, maybe better notes than you do in class. Use up the margins, write your extra notes, write questions out in the margin that you can ask each other, you can post on My Big Campus, or just finish the notes and then make sure by the time you're finished that you have a better understanding of those questions you wrote as you went along. Okay, make sure if that you're pausing, if I'm talking too fast, that you're rewinding and rewatching any examples that you're not so sure on, or that you rewatch the entire video. Maybe you watch it twice in a night, maybe you watch it once tonight and once before a quiz, or something like that. If there's anything you're not sure of, you can always go to Khan Academy, or you can go to the online textbook and watch the videos. It'll be the same kind of presentation, but in a different words, different format, so that you've heard it 2 or 3 times. You have to come to class knowing the material, otherwise you won't be able to do the work in class, and it won't have done you any good. Okay, so here we go. This is the last of all the PQ business, and we'll practice on it a little more next week, but this is the last of the new material. So today we're going to talk about biconditional statements. So a biconditional statement can be written in the form P, if and only if Q. This IFF stands for if and only if, and you don't probably want to write if and only if. That's a lot to write, so we use this IFF. All that means is P if Q and Q if P. That just means that you can write the conditional statement using either term as the hypothesis and either one as the conclusion, so you can read them back and forth. And this is the symbol right here for a biconditional statement. Notice the double-headed arrow indicating that you can read it P to Q or Q to P. So you'll see when we get into these examples that you'll be really able to read the sentence forward or backward, and it'll make sense either way. Take note of this symbol right here. This shows up on a test, on the Chapter 2 test, and it's really a common missed question because people just skip over it. Okay, that double-headed arrow is the biconditional. P if and only if Q. Okay. So for the entire thing today, I'm going to use the yellow highlighter as the hypothesis and the orange as the conclusion, just so I can keep straight which way I'm going. Okay, so this first one here, they've given us a biconditional. 2 angles are congruent if and only if their measures are equal. So we're going to separate it first into the hypothesis and the conclusion. Now, instead of looking for if and everything after the word if, and then and everything after the word then, the hypothesis and the conclusion is really easy to find because they're separated by this if and only if right here. So everything before if and only if is your hypothesis. Ooh, that's smeared. Everything after if and only if is your conclusion. Okay? So just take a second to rewrite those. So the hypothesis will be 2 angles are congruent, and the conclusion will be the measures are equal. Okay, so now that we have that done and we've separated a hypothesis and conclusion, it's really easy to write the conditional and the converse that makes up this 2 biconditionals. So we studied conditional and converse yesterday, or today rather if you're watching it at night. So we're just going to write the conditional. If 2 angles are congruent, then their measures are equal. Okay, so just like we did in class today, if the hypothesis, then the conclusion. And the converse, remember from class today, is the opposite of that. So where we write the conclusion first and then the hypothesis. So in this example, that would read, if 2 angles measures are equal, then they are congruent. Remember, like we talked about in class today, you want to keep the proper noun in the hypothesis, and then you can use the pronouns in the conclusion. So if 2 angles measures are equal, then they are congruent. So if I were to do this question backwards, which we will in a second, you would take these 2, conditional and converse, and put them into a biconditional. We're basically deconstructing the biconditional on this one. Okay, pause right here and take this second example, example 5b, and see if you can do it by yourself, and then come unpause it and let's see if you got it right. Okay, so pause and go. Okay, so the second example says Bobby is a member if and only if he has paid the $5 dues. So the hypothesis is Bobby is a member, and the conclusion is he has paid the $5 dues. So the conditional will be if Bobby is a member, then he has paid the $5 dues. And backwards, the converse, if Bobby has paid the $5 dues, then he is a member. Okay, I hope you got that right. If you didn't, you probably want to pause, rewind the whole video, and watch that example all over again. Okay, the next example, this time they gave us the conditional statement and they want us to write the converse and then the biconditional. Okay, so we did the first part of this, writing the converse, today in class. So this should be a review. Here I'm going to highlight the hypothesis. The date is the 4th of July. And the conclusion. It is Independence Day. Okay, so remember, converse is Q to P. So I'm just going to write this sentence backwards. If it is Independence Day, feel free to abbreviate. Then the date is July 4th. Good. So there's our converse just written backwards. So now we need to put this into a biconditional. So you can refer back to the two examples on 5 where you saw biconditionals written, and notice that all you have to do is write the hypothesis, if and only if, the conclusion. So you don't start with the word if, you just start right in with the hypothesis. The date is the 4th of July. Oh wow, it would help if I could spell July. If and only if it is Independence Day. Now, you could have just as easily written this biconditional, if it is Independence Day, then it is the 4th of July. Because the biconditional can go forward or backward, it doesn't matter which order you write it in. I just choose to write the hypothesis given first and then the conclusion next. But you could have written it the other way around and that would be still as correct. Pause right here, work on example 6b, and let's see if you get it right after you're done. Okay, so 6b says if points lie on the same line, then they are collinear. So points lie on the same line as your hypothesis. They are collinear as your conclusion. So the converse, Q to P, I would write if points are collinear, then they lie on the same line. Remember, I kept that proper noun in the hypothesis, and then I used my pronoun still in the conclusion. The biconditional, points lie on the same line if and only if they are collinear. Good. Okay, now let's talk about truth statements. For a biconditional statement to be true, both the conditional and the converse must be true. That's why we spent so much time on the example 5 and 6 pulling out the conditional and the converse, because that's how we're going to tell if it's true or not. We're going to read each conditional, true or false, converse, true or false, and then we can decide. Otherwise, you can't just read the biconditional and tell on its own. Okay, so they both have to be true for the entire statement to be true. Okay, last page here. Alright, determine if each biconditional statement is true. If false, give a counterexample. So, the biconditional says an angle is a right angle if and only if its measure is 90. So, an angle is a right angle is my hypothesis. Its measure is 90 degrees is my conclusion. So the conditional will read, if an angle is a right angle, then its measure is 90. Okay, so if an angle is a right angle, then its measure is 90 degrees. That's a true statement. That's the definition of a right angle. Okay, then we flip it. If an angle measures 90 degrees, then it is a right angle. That is also true. Okay, so, here's your fill in the blank. Since the conditional is true and the converse is true, then the biconditional is true. Both forward and backward were true, so the whole thing is true. So I don't need a counterexample because it's a true statement. So there's only counterexamples if something's false. Okay, pause right here and try example 7b, and let's see if you get it right. Okay. B says y is -5 if and only if y is equal to 25. So y is 5, -5 is the hypothesis, y squared equals 25 is the conclusion. So if y is equal to -5, then y squared is 25 is the conditional, and backwards, if y squared is equal to 25, then y is equal to -5 is the conclusion. Okay? The conditional statement is true because you know anything squared, so this would be -5 times itself. -5 times -5 is positive 25. So this first statement, the conditional, is true. However, the converse, if y squared is equal to 25, then y is -5, is not true because y could also be positive 5. Remember, when you take the square root of anything, y squared is equal to 25. When I take the square root, there's actually always a positive and a negative answer that come out of that. Sometimes we let you throw away the negative answer, especially in geometry, because we're usually talking about angles or side lengths, things that can't be negative, but it's always there even if we don't use it. So we needed it in this case. Plus or minus 5 is the answer to that. So the conditional is true, but the converse is false, which throws the whole thing out. If either one of them is false, then the whole statement is false. Okay, a little fill in the blank here. In geometry, biconditionals are used to write definitions. Now you know a definition is a statement that describes a mathematical object and can be written as a true biconditional. So like we were talking about the definition of a right angle up here, we wrote it as a biconditional and it was true forward and backward. That's what we're going to do down here for a couple of other objects. Okay. A good, precise definition can be used forward and backward, and that's why we choose to use biconditionals. So let's look at this first example. Write the definition as a biconditional. So here we have the definition of a triangle, and it's a three-sided polygon. When you write these as a biconditional, you have to add in some of your own words, usually in the hypothesis, to kind of classify what you're talking about and help people get started. So the way I would write this one, I would say a figure is a triangle, if and only if it's a three-sided polygon. So I used all the words that they gave me, but I needed like a qualifier word here. A figure, a shape, an object. You could have chosen any of those words to describe this. You could say something is a triangle, but it's better if you can clarify a little bit more. A figure, a shape, an object, something like that. So a figure is a triangle if and only if it is a three-sided polygon. Because this is a biconditional, I could have just as easily written this the other way. A figure is a three-sided polygon if and only if it's a triangle. Either way would be correct. Okay, take a second and try example B and see if you can write a biconditional for straight angle. Okay, so I wrote an angle is a straight angle if and only if its measure is 180 degrees. An angle is a straight angle if and only if its measure is 180 degrees. You could just as easily have written yours backwards. An angle's measure is 180 degrees if and only if it is a straight angle. And either of those would be appropriate. Okay? Now, when you come to class tomorrow, you're doing what would have been your homework in class. So make sure you understand what you're talking about so that you can get into class and know how to do the homework. Otherwise, this is all for naught, okay? So go back over the video, rewatch any examples. You can go to, like I told you in class today, khanacademy.com, and you just use the search bar where you could search biconditional statements, or you can go to the online textbook, go to chapter 2, section 4, and you will see a red tab that says video or video tutorials, something along that line, and you can watch the tutorials for this video. Each example is its own separate short quick video. So try those out if you're still not understanding before you come to class. Okay? All right, good job, and I will see you on Monday.